Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to watch it later. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speakers, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions. And we will take about 15 minutes near the end of today's webinar and go through those audience questions. And also at the end of today's webinar, we are doing a drawing for 3 $50 Amazon gift cards. So please stick around. Hopefully you'll be one of our 3 lucky winners. Okay, with that, we'll kick off today's webinar, which is DevOps Today, Self-Service NoOps Tomorrow. Our speakers today are Travis DePuy, who is Head Product Evangelist at xMatters, and Andi Grabner, who is DevOps and ACE activist at Dynatrace. Welcome, gentlemen. Thanks so much for joining me today.
Thanks for having us.
Thank you.
Awesome, awesome. All right, Travis, I know you're kicking us off, so I'm going to put myself on mute and turn it right over to you.
Yep, thanks for that. Welcome, everybody. Just to give us a quick rundown on what we're going to talk about today. We're going to go over self-healing and NoOps and why are people making these moves into this new paradigm. Then we're going to talk about moving to NoOps as self-service, really kind of around scalability. A little spoiler alert there. And then we'll get into self-healing and then NoOps use cases, so you can actually kind of see what it looks like in the real world. And then we'll talk about kind of the future. What are the next steps? After you've kind of achieved this, beautiful nirvana. And then we'll follow that up with the Q&A sessions. So what is self-healing and what is NoOps, and why are teams making the move? Andy's going to go over that for us.
Yeah. Well, also, hello everyone that is on the line today, wherever you are. I know, Travis, you are in sunny California, right down in San Diego.
Yes, sir.
You're probably enjoying the heat. I'm sitting here in Austria. It's already dark outside and cold, and I think it's been raining all day. So it's definitely great to sit in here and now, talk about something that is dear to my heart and that also kind of helps me, warm up, because I think there's a lot of excitement here. So first of all, Travis, earlier you said I think in the first agenda slide you had NoOps, the term NoOps 3 times. And I could assume that this freaked out a couple of people, because that typically when I talk about NoOps, then they say, so you're taking away my job, what's going on with you? It's not possible, there's always somebody in operations, and that's completely true. So that's why I typically explain kind of the transition from DevOps to NoOps to what we now call ACE, in the way we actually transformed our organization at Dynatrace, right? xMatters and Dynatrace, we are close partners, and we both went through our transformation in our history as software engineering organizations. In our case, we started with DevOps a couple of years ago, which was when we actually switched over from our traditional product to our SaaS offering. But not only did we deliver a new product and develop a new product, we also inherited and started owning production. So what we tried to do is started to automate things that used to be done by ops as if a dev would do it. So that's why ops to work like devs. So we tried to figure out how can we do all this ops work to work like the devs would do it. That's why we started infrastructure as code, automatically standing up our different environments, both in production and also in pre-prod, to really automate our complete delivery pipeline. The goal was 1 hour code to production. This was a request from our CTO and founder. He said, if we are going to deliver a new product, we need to deliver it with speed, and the speed that the market demands. So this was kind of our first iteration, what we call DevOps. The second iteration then was about how can we bring stability into the picture, because as we started to ramp up the speed, we delivered more and more features, more and more updates. We also saw that unfortunately we had some quality issues, right? We started our developers, they cranked out a lot of new features, and I know, Travis, you probably see this with other people as well. Fast alone doesn't make you deliver better quality by default, right? So what we then actually said, okay, we really need to get into this NoOps mindset, and I think this is what I also try to make sure that people understand. NoOps doesn't mean there's no operations anymore. There's of course people that take care of the underlying infrastructure, whether this is your infrastructure or your cloud infrastructure. But the change in mindset is that whatever you do as an engineer, you have to think like an ops. You have to think about what can potentially go wrong with this code change and how can I avoid it through automation, either in the pipeline or in operation. So really built in automation that make it possible for this component that I'm developing to either scale up on demand in case there's an increase in load, scale down in case there's no demand anymore for the resources, fail over, fail back, turn off certain feature flags. This is what this is all about. And from our perspective, we saw the big benefit in the end. We saw a reduction of end user impacting issues of 93%, 93% fewer impacting issues, because on the one side, we detected a lot of problems early on. We will talk about this later, how we integrated better quality control into the delivery pipeline to stop bad code changes from going into production, but then also invested in self-healing capabilities in operations. So Travis, this was speed and stability, right? So better and faster. It sounds like this is the end of the game, right? We're done.
Is it? Is this the end?
Yeah.
Are we done? We'll go home.
Oh yeah, there's something blank on the screen here. So let's see, what's the last thing? So just as we at Dynatrace, yes, we are developing one major product that people know about Dynatrace, but just as any other organization, we have a lot of engineers that are not only working on the core platform, but they also develop a lot of other software that supports our business, our backend systems. We call it our paves, our licensing, our customer support system. We have a lot of different teams that are scattered around the globe that are also developing software. And instead of them having to reinvent DevOps and NoOps like we did in our core product, we said, let's not waste engineering resources to reinvent what we've already done. Let's figure out a way how we can scale what we build in our initial phase and give it to the rest of our engineering organization so that they can leverage NoOps as a self-service. That means they can really focus on writing code, but they need to do it in a way so that they always keep in mind, remember, DevOps is a mindset. It's about what can potentially go wrong. So we enable them through a platform that makes sure that bad code changes cannot make it into production. And in case they go into production, they can leverage the self-healing capabilities. This allows us to really scale out to a larger engineering organization. And that's kind of our transformation from DevOps via NoOps to what we now call ACE, Autonomous Cloud Enablement. It's about enabling our engineers to become more autonomous with the cloud technology we have available. Does it make sense?
Yeah. Yep.
Awesome.
It's helpful.
Yeah. All right. So to really reinforce, right, folks, don't get scared about NoOps. NoOps truly is a mindset. It's about what can potentially or possibly go wrong and how can we prevent it through automation. And this means a lot of things. It means how can we put more safety nets in our products that we develop? How can we build safety nets in our pipelines? How can we use tools that actually help us in automation, in automating remediation actions, right? Because in the end, we want to make sure that the stuff we deliver is really delivering value and not bringing pain to people that may no longer be able to use the software that we're delivering. So it's a mindset, and how can we bake this, into our minds and into our organization, to our culture. Now, one thing why I believe this is very important yet, and not all people are there yet, is we did a survey was last year, early 2019, with a bunch of our customers that have told us, hey, we are already doing great things. We've broken up the monoliths into microservices. We're deploying on these new platforms. Yet when we asked them the question, so how fast do you innovate? How long does it take you to deliver? What's your speed of delivery? Then they were telling us that the majority said, well, it takes us 12 and a half days. So the majority still takes a long time to push stuff to the pipeline. But the other thing, and I think, Travis, this is something that is dear to your heart, is MTTR. So once you deliver something, how long does it take you until you detect there is actually an issue with this deployment, until you actually found the right people to figure out what is the root cause, and then remediate the action. And so there's a long way to go to really get everyone to what I call the top right here in this magic quadrant, right, to the top right, to deliver on the promise of speed and stability, and then scale it to the whole organization. So it's a long way to go. But fortunately, we also have some answers, right? How you can get there.
Real quick, Andi, is this the website if people want to go see that survey, take the survey?
Yeah, exactly. So the dynatrace.ai/AC survey, I can recommend everyone, assess yourself. It asks you a bunch of questions. It doesn't take you long, but it also forces you to think about, first of all, do we actually have these metrics available? Do we know how many incidents we have? Do we know how long it typically takes until we assign it to an engineer, until we actually solve the problem? How are we delivering right now? So this is a way to assess yourself. Plus, you also get the results later on how you're doing as compared to your peers.
Yeah, just to reiterate, we're finding also that people are, trying to balance that uptime versus innovation. So we did our own survey. I don't think the survey is open anymore, but we found, some surprising, but also some pretty not surprising, results. So, the vast majority think that customer experience is a priority in their roles. That's pretty good. It seems like people building the systems, want to make sure that customer experience is high in their priority stack. Then we found over here in the bottom left corner, you see that about 54% of respondents were delivering weekly or daily even. And I think we're seeing that number increase, as teams kind of adopt these, this DevOps mindset, or this, run it and build it kind of mindset. And then about 3/4 of respondents said that customer impacting issues affect their feature velocity, which can impact their customer usability, and stability. Yeah, again, not surprising, as you're releasing more, a lot of times you're kind of having that trade-off of, okay, we need to put in more features, but okay, now we need to focus a little bit more on stability. Throw in a bunch of stuff, it becomes unstable, but you throw in all stability and then you have no feature, no features. I think the most interesting piece, though, is that over half found that these weekly releases were correlated to weekly degradations in experiences. So there's definitely this, people are feeling that impact of, of adding features, and it's impacting the stability. But I think with the rise of, these SRE practices, we've seen this transition to run and build instead of just run or build. So that teams are kind of melding together, so to speak. But this means that the developer teams are a lot more aware of what needs to be monitored, or what needs to be paid attention to. This, you can see in the SRE book from Google, they talk about the 4 golden signals, as these latency, error, saturation, and traffic as, metrics that are hugely important in understanding the health and stability of a system. But before, constraining using a corporate mandate, to kind of constrain feature velocity, just so that you can, so that you can make sure or ensure a high level of stability, is not going to be widely received. If you have to introduce the change advisory boards, that's going to hinder your progress. So really, the question becomes, how can NoOps be rolled out to these wider audiences without sacrificing velocity? So Andy's going to talk about that in more detail here.
Yeah. So the next section, I really want to talk about, we talk about NoOps, and I told you about my experience, or our experience in our organization. And I think we see that everybody feels the same pain of, going fast, but making sure the stability works, and then how you can scale it into your organization. People then typically ask us, so how do you do it? This is a big bang thing that you change. And I said, no, typically not, right? I mean, there's building blocks. People like building blocks. You want to have small steps. And I already have like 4 big blocks for you. And typically when we work with organizations, we break it down even further into smaller areas. But let me show you what I mean with this. The first building block, and Travis, right? We talked about a lot of metrics earlier. So I think the most important thing is we need to actually monitor and measure everything we do. Because if you cannot monitor and measure, if you don't know how you're doing, if you don't know these, you mentioned, I think, throughput, failure rate, resource contention, right? There's a lot of core metrics that we need to understand how a system is currently behaving, because otherwise, if we change something, we don't know in which direction we change it, to the good or the worse. Now at Dynatrace, we are, I think, pretty good in monitoring. So the first thing that we tell our customers is the first thing you need to really figure out is how you automate monitoring. How can you provide monitoring and observability automatically with everything your organization is doing? And no, we're not talking about operations only, we're talking about every single environment, because you need to monitor and understand the impact that an individual code line, a configuration change has, and not only when it ends up in production, but already earlier. This is why the first step is automating monitoring, and I actually like to call it monitoring as self-service, which really means I, as an individual, I need to be able to get the data at the right time to make the right next decision. But it needs to be data that is relevant to me, and it needs to be data that I need to be able to retrieve, let's say, through a chat interface where I say, how is my current build doing that I just deployed? Or it needs to be me, maybe not as me as a person, but maybe as a tool, right? I need to be able to get data in an automated way so that I can trigger things based on data that might not look that great. But the most important thing is you have to automate monitoring so that we can get the right data at the right time to the right people or tools to make the right next decision. It's the fundamental piece. Monitoring is key. Now, the next step is we have seen a lot of organizations, fortunately. Let me see if the click here gets me to the next animation. Perfect. Automate quality. Talked about quality a lot. Now we see a lot of organizations, fortunately, have invested a lot in automated testing. We see more and more talking about automating the performance environments, continuous performance environments, where they, on every build, they execute their performance tests either in an environment that they're currently standing up for that particular test, or even a continuous performance environment, which is an environment that is constantly under load, and then you deploy a new build in there, and then you figure out how does it change. So automate quality here, I also like to call it performance as a self-service, is about, and Travis, just the 4 metrics that you talked about earlier with the SRE practices. Give me these key metrics that define my ability to scale the way I use my resources, the way I perform. Give me this feedback with every code change that I do. So here, this is all about building a performance best practice, a quality best practice into your delivery pipeline. So with every build you push through, you not only get functional, everything is good, but you also get, we're scaling great, performance is awesome, we're not messing up with the resources, and we actually know how to also react to problems. This is also the area where we see a lot of our people that we talk to enforce things like chaos engineering. So you have a performance environment, and then you bring chaos into the environment and actually figure out, does the system behave in the way it should also react in production in case there's chaos coming in. Okay.
Yep.
Does this make sense still? Yeah, perfect.
Yeah.
So after automate monitoring, it's about automate quality, automate performance. I like to also call it performance as a self-service. Now, the next piece of the puzzle is, and we've seen, fortunately, over the last couple of years, that more and more organizations became mature enough to really automate the delivery pipeline. So a lot of tools out there that do continuous delivery. What we have seen is a lot of organizations still spend too much time in validating a deployment, whether it's in pre-prod between stages, where after they run a build, they run some tests, and then they are pulling up the different dashboards of the different tools, figuring out good or no good. So we want to automate these quality gates. We have the capabilities. Most of these tools have automated ways to pull back the data through an API, so we can fully automate the quality gate enforcement in a pipeline between stages. So that's one aspect, speeding up the quality assessment. The next thing is, if you're deploying into a production-like environment, and if you do things like canary deployments, blue-green, or feature flagging, you also want to automatically use your monitoring data to validate, is this a good canary, a bad canary? Is it a good feature that we just turned on, or is it not good? And then automatically making the decision whether the canary should be rolled out to the rest of the world, or whether you better want to pull it back before you give it to your customers. So this is about automating the delivery process by enforcing quality gates, stopping bad code changes before they go into production, and also validate production deployments. I also like to call it the unbreakable continuous delivery pipeline. Kind of, we are stopping the pipelines from breaking production. That's why it's unbreakable.
That's so this is all before you even get to production, right? So you're already knocking out potential issues or identifying, quality issues or stability issues before it even reaches the customer experience, right?
Exactly, that's the idea, right? Because every problem we can prevent from happening, the better it is, because then we need to deal with the automation in production. Yet, even though as much as we invest here, right, there's always going to be things that happen in production. And this is where the fourth building block comes in. It's about automating operations. This is really about, you have something, you have a system running in production, and some unfortunate event happens. And then we have, I believe, two major options here. The one is a business remediation task, which means inform the right people that need to be informed about a problem. This could be proactively reaching out to your customer base, maybe apologizing and say, hey, we're experiencing some problems right now, we're working on it, come back later. You may want to proactively inform your support team so that they know there might be an influx in people complaining about it, like opening up support tickets or calling into the call center. But you can also already proactively notify maybe your product teams about, hey, something is wrong with this feature flag, or something is wrong with this environment. So that's what I call the business remediation. That's kind of the red arrow on top. It's a little hard to see, so escalating it. But the most interesting thing now is, from a technical perspective, is auto mitigation or auto remediation. This is where we can then trigger tools where we can give the monitoring data that tells us what is the impact and what is the root cause, give it to a tool that can then execute the right remediation actions to bring the system back to its healthy state. And this is where the whole notion of NoOps, this, I know it sounds mythical, and or the self-healing aspect, it sounds mythical, but it is really possible, even though maybe self-healing is a little too far-fetched as a term. I mean, as a non-native speaker, I like self-healing. I know if as a native speaker, maybe self-healing, that's not really possible. I think it's more like we want to automate the mitigation as good as possible. So we want to do things to bring the system back into a healthy state. That's the whole idea.
Or even a potentially temporary healthy state while you work out a longer term resolution. Yeah.
Exactly. Like, do I want to wake up people at 2 o'clock in the morning, or do I want to apply a temporary solution so that we have time until 8, 9 o'clock in the morning when the rest of the engineering team comes in?
Yep.
Yeah. Good. So these are the 4 building blocks that we have, the path to NoOps. And what we have done, and also thanks to your organization, to xMatters, and especially you in person, right? We've worked together to not only build great integrations with all different types of tools that are out there, but we also built and open source the project that we call Captain. It sounds weird, KEPTN. This is the German phonetic for a captain. It basically, as you say here, it simplifies your journey to NoOps for cloud native applications. We're currently, earlier this year, we actually were we're now part of the CNCF landscape for application delivery. But what Captain really is, it encompasses a lot of the best practices for both continuous delivery and also for automated operations. It's an event-driven control plane for cloud native that is orchestrating all the different tools to make sure that artifacts that your developers push out are correctly tested and analyzed and are stopped before production in case there is a problem. And in production, it also then orchestrates the integration with the different tools to make sure that problems are remediated. So we are still in the early stages of this project. We have our first users. We use it internally. We also have the external users already. Very happy if more people are kind of taking a look at it and giving us feedback and telling us, it's an open source project, contribute, but also tell us in which direction we need to go. Now there's 2 major use cases that I want to quickly highlight. I want to start with the first, and then Travis, I'll let you talk about the second one, because this is also where you have built integrations with xMatters. The first use case is about how we solve the continuous delivery problem, which means in Captain, we believe in the separation of concerns, which means when you set up Captain, you define your process in what we call a shipyard file. That means how many stages do you have? Do you want to have staging and production? Do you want to have dev stage production? You also define what type of deployment and test strategy you want. That's in one file. In another file, you specify which toolings you want. So complete separation of concerns, the people that define the tools, the people that define the process. And then you also have the configuration elements that your engineers bring to the table, your artifacts, your test files, your SLIs and your SLOs. It's all separated, it's all obviously version control. But the way this works is once you set it up, you give Captain a new artifact, a new container. Captain will then take this container, will first update the configuration. It updates your Helm charts or whatever you use for deployment definition. Then it will actually update your environment. So it's all event driven. You can choose really which tool you really want to use for the actual deployment or updating the environment. In this case, Captain is deploying a new version next to the old one, as you can see with the blue-greenish color here. So update the environment. Then Captain issues an event to run the test. It could be JMeter, it could be Neotis, it could be Gatling, it could be any of these tools. And then at the end, we have a component that we call Lighthouse, which is then validating the quality of the build that was just pushed through by pulling in metrics from different data sources. It can be a Dynatrace, it can be a Prometheus, it could be a Neotis, it's all extendable. So pulling in the metrics that the developers told us in the SLIs, what is important, then comparing them with the SLOs, what are your objectives? And then at the end, coming up with a score. So we came up with a scoring algorithm. We are not the first one to do this, but that's also, we do it. Scoring, yeah, exactly. If it's bad, we roll it back, right? We want to make sure that even if this is a pre-production environment, we want to keep it stable, so we roll it back. But if it's good, right? If we reach enough high score, then we would promote it into the next stage, which means Captain is actually then rinse and repeating it for however many stages you've specified in your process definition, which we call the shipyard file. So this is kind of continuous delivery, right? We make sure that only good stuff ends up in production, and that's very important. Travis, automatic remediation. This is why you have more experience in production. How does that work?
Yeah. So ultimately, you're going to have issues in production, right? And it's not so much. You can get to this nice utopia of fully self-healing systems. But you have to look at the whole system as self-healing. So that might include these production alerting, monitoring, and then as well as alerting. So if you look at it from kind of that holistic view, you can have this whole this self-healing system that just involves several different kinds of tools. So for example, you've got an alert, either detected by Dynatrace or Prometheus or something, and we can get some kind of remediation action, and then using a tool like xMatters, actually execute that remediation action, either using a human's decision point, so you sending the actual alert to them and say, okay, human, here's some information, maybe we've enriched that original signal with some additional context that then they can take an action, on that, or we could do it before the human even gets aware of the issue. So again, going back to your 2 o'clock in the morning, maybe we'll just try and increase the disk size, or just try rebooting the server. If this is 2 o'clock in the morning, maybe it's not a critical thing, but let's try rebooting the server. Then it alerts again. Then maybe we look at firing an actual, waking the human up at 2 o'clock in the morning. So rolling back to an old version, blue-green deployments are kind of this nice hybrid of ready to go deployments, but also canary deployment. So you can kind of target one, either blue or green, as your production, and then roll things out to the opposite one and use your load balancer to figure out which one's going to be serving traffic. And then after that, then you can revalidate this quality gate. So again, if we then fail from that point, all right, now we need to go find a human, or maybe now we need to escalate and get other additional groups involved across a variety of channels, right? Slack or xMatters or MS Teams, kind of whatever your tools are using, actually getting people involved in this kind of thing. From the xMatters side, this this is kind of what it looks like. Over here on the right side, you can see the actual notification that I can get from xMatters. It's got some additional information about the original alert, maybe from Kepton in this example. And then this new push notification has a couple of response options you can see here up on the right side. So I've got your standard on-call escalation, on-call lifecycle stuff for acknowledge and escalate. But then I've also got this rollback deployment. So when I execute that rollback deployment, you can see over here on the left side, the flow designer, I built this out that my response option for rollback deployment is going to go create a JIRA issue. And then it's actually going to trigger a command in Kepton to roll back, maybe to the last deployment or the green deployment or whatever. And then we'll update the JIRA issue, with the results of that. So great, it worked out great. All right, fine, let's close the ticket, or it didn't. So let's document the ticket so that we can then figure out why it didn't work, and then maybe get somebody to fix the rollback or fix the command script or whatever.
Can I ask a quick question? So you actually, who is on call, exactly who to, send the message to, even if it might be escalated in the middle of the night. So that's actually great, because you have exactly who to target, and then you can, in the flow designer, define your workflow, which includes calling all these other tools and then actually do a certain action, but you can kind of prescribe it. What you give the options to the user that you are alerting, right?
Yep. We can give that option, right? So actually that kind of tees this up well. So this is showing a different process. This might be some kind of process crash directly from Dynatrace. So this here on the left side, I can see the actual inbound HTTP listener from Dynatrace. It'll parse the payload, and then we'll create a JIRA issue, okay? And then from that point, okay, let's actually put in some kind of logic, to figure out what to do next. Maybe in this case, this is an error, so okay, this is really a problem. Let's go ahead and page somebody out, and then we'll update the JIRA issue, as well as update the problem in Dynatrace. So using this kind of workflow tool, we can then kind of convene all these different signals into one place, and then send them back out to the relevant places they need to go. Kind of on the right side, you can see the same kind of responses that I've got there: acknowledge and escalate. They'll just post some information back into Dynatrace to say, okay, Joe Bob responded, with this particular information at this particular time, which can really help for the post-mortem. Then you can see, okay, these people were notified at this particular time. This person said that they would accept. And so you have these nice timestamps of who was notified about what information, at what point. But additionally, then the real power comes in with these other response options. So maybe I need to start the major incident. We're like, oh crap, we need to get bigger. This is a bigger problem. We need to get some more teams involved. So we can execute that process. Again, we talked about remediation or rolling back, the last deployment there. So there's a variety of different tools, that are shown here, and they're all kind of, put together with this nice workflow engine. And again, kind of stepping back, if you think of self-healing systems, not just as, Kepton or Dynatrace or, the monitoring tools, it's this whole ecosystem of tools that from end to end, can be self-healing.
And the great thing is, I believe all these tools that we are representing, obviously 2 companies here, but there's a lot of tools out there that you're integrating with, right? I see Slack, I see Jira, I see Ansible. Fortunately, by this time in our industry's age, everything is automatable. The APIs allow us to do a lot of magic things by integrating these tools well together and really deliver value to our organizations, to our customers, so that they can build automation and automating a lot of things that used to be manual, and now it's fully automated, but still having the ability, like what you guys provide, is still involving a human, in case you need a decision that you cannot automate right now. Then hey, what shall we do? Here are some prescriptive options. What's the best thing to do?
Yep, we have one customer who actually puts this really well. Hands-on keyboard. Maybe so running some pre-remediation actions, that we talked about, and then ultimately at some point, some issues are really just going to need somebody to sit down in front of a computer, dig out their debugger and really dig into those issues. Yeah, so we built this. So this is the flow. What you're looking at here is the flow designer from xMatters that we put together, really to enable this kind of really easy, tool set, to build out these workflows that reach into all the different tools. This last slide just kind of reiterates, kind of what we talked about. But you can kind of see over here on the left side the problem from Dynatrace, the notification from xMatters with the response options. This is showing the push notification, but it's SMS and voice as well. And then I can see up in the top right corner the Dynatrace, the problem, the Jira issue that gets created with the Dynatrace problem details. So again, even in Jira, we have the details from Dynatrace. And then finally, the Slack channel, that was created to then start the troubleshooting issue. So then we can have this association between the Dynatrace problem, the Jira ticket, and then as well as a collaboration point. Really nice for the postmortems. So you're like, okay, crap, what went wrong? Who did what when? Okay, cool. Let's collect all that information. Let's learn from it. Let's build out those, self-healing processes to really improve this. Okay, so really, Andi, where do we go from here? What does the future hold for us? Tell us.
Well, the future is both of our statistics or our surveys showed us there's a long way ahead of us for all of our organizations, for all the people that we work with, for all the people in the industry that try to deliver better value faster. Not only deliver better value faster, but with the right quality, with the right stability. So I think we just will hopefully see more people changing their mindset towards a NoOps mindset, not freaking out about that NoOps means no operations, but it's really a mindset about what can we do from when we start defining an architecture in software, what can we do while we develop software so that every potential change is not causing a problem. So always think about what can potentially go wrong and how can I prevent it? What type of monitoring do I need to put in place in order to understand if my system is healthy or not? What can I put into the system so that I can heal myself? What do I need to put into the system that I can integrate with tools like xMatters to then give the right remediation actions either to another tool or to a human, right? So I think this is what we need to do, and we need to make this as easy as possible for everyone to build software that is automatically validated and then can leverage these self-healing capabilities. And that's why I also said in the beginning, for me, yes, NoOps is a mindset, but we need to build the tools, we need to provide the platforms that integrate all these tools, and it has to be as easy so that everybody can use it like a self-service, right? It has to be as easy as taking a picture on your phone and posting it on social media and then being happy about the likes. It has to be as easy to deliver software, post it out there, and then hopefully you also get likes and stars on your app store, right? I mean, that's how easy it has to be.
I don't know, raise your hand if we should bring back change advisory boards. I mean, let's get a whole committee, to decide on these code changes.
So yeah, so I think this is the big thing, and I know it's a lot of cultural change. It also means organizational changes, but I believe we have a lot of we are very happy to not only share our slides and stories here, but whoever is interested in learning more, just reach out to us. And I believe there's actually something we have to as kind of giveaway for folks that are listening to this, right?
Yep. Yeah, we've got a self-healing DevOps kind of white paper that goes over kind of a lot of what we talked about, recommendations, and I believe it has some of the results. Yeah.
Perfect. And then I know we talked about Captain a lot, but give Captain a try, check it out. Even it might not be the perfect fit right now, maybe for your existing projects, give it especially for cloud native projects. I think it really gives you a head start towards implementing NoOps as a self-service. Join our community, give us feedback, do it like our friends here at xMatters have also contributed, so that's always great, right? Tell us which tool integrations are needed. It's very easy, it's all event-driven, you can write your own integrations. We've also seen people using Kaplan integrated with GitLabs, with Argo. We've seen it integrated with xMatters. We've seen it with integrating it with different testing tools. This is all possible. And as I said, if maybe the time is not right yet for you to use it full-fledged, take in the experience what it feels like to have a NoOps as a self-service available, that You just have to give a container, your SLIs, your SLOs, and your remediation files, and then it will just take care of you. So see this as this is where you need to go. This is the type of platform you need to build, and be inspired on what we are giving you here as a as a reference implementation.
Yep, I think it's a good point. Always, the industry is changing, so fast, but ultimately you need to kind of have a path to get there, and ultimately it's all about adding more features, but also doing that with stability in mind. And I think, a lot of tools we talked about today can really, help teams kind of, achieve that, to get somewhere, get their feature velocity, but without impacting customer experience. It's the name of the game, right?
Exactly.
Great. Thanks, Andy. Are there any questions in the audience? We'll open it up to questions.
All right, great, guys. Thanks very much for that. We do have plenty of time for questions, so if you have a question for either of our panelists, Travis or Andy, please go ahead and use your GoToWebinar control panel and submit your questions. And let's go ahead and dive right on into what we've got. Here's the first one. What are the three must-have components, be it tools or processes, for autonomous cloud? And what features should I look for in my apps to make sure they'll work for this?
That's a loaded question. So I think first of all,
Captain, obviously.
Yeah, no, I think from a software perspective, in order to do things like this, in order to be able to push a piece of software through a pipeline that can then enforce quality gates and can do self-healing, you need to have the right architecture in place, right? You need to build software that can be monitored. You need to understand, you need to know what are important indicators, quality indicators. You need to be able to define your SLIs. You need to be able to monitor those, and then you need to be able to enforce it along the pipeline. Also, in order for, Travis, right, if you give people the option through xMatters to say scale up or scale down or restart or roll back, this is something you obviously need to factor in and architecture into your software stack, because it just doesn't magically happen. What I always say, just taking your existing monolith and putting it into a container and then deploying it on Kubernetes doesn't make you cloud native and doesn't give you all the benefits. But I know there's a lot of organizations out there that start like this, and then they wonder, why are we not able to deliver better with better quality? So the architecture needs to be right. I think the next thing that's very important from an organizational and cultural perspective, it's the role of who is responsible for what. I see more and more organizations moving towards shifting responsibilities towards the left, meaning towards development, meaning empowering them with the right platforms so that they can deliver value to production, so that they are able to deliver into production, but then also they have to be responsible for what's happening in production. But in order for that to work, really the underlying platform needs to have these capabilities that we discussed today, right? It has to have automated quality gates so that I cannot make any bad mistake. And it has to have self-healing capabilities so that as an engineer, I can make sure when I deliver code, I can also deliver my SLIs, my SLOs, and my remediation scripts so that the platform will take care of most problems for me, and not that I have to wake up at 2 o'clock in the morning, because your engineers probably will tell you that's not the job that I've signed up for in the beginning, right? So that's important.
All right, great. Next question here. How do you, how do you reconcile remediation processes that need to occur across multiple service desks, like ServiceNow and Jira?
I'll take that one. I think, if you think about large enterprises or any company, over a given size, they're going to have multiple service desks. For a variety of reasons, right? Each team kind of has its own process that it wants to do. There might be, some kind of corporate standard, but ultimately there might be other places that you need to shunt, information. Yeah, so keeping those in sync, for example, actually here at xMatters, we use, Zendesk for customer-facing, issues. And that's where our customer success teams, work out of primarily, in addition to support. but then engineering teams use Jira. So having free flowing information between the two can really help facilitate the conversations that those teams need to have. I mean, I would almost throw in Slack or a chat application in there as well, because all three of those kind of tools need to have at least some parts of the information about especially critical incidents, right? Depending on which team needs to be there, as much as I'd say that the RACI matrix informed, consulted, or responsible. So yeah, I think it's important to keep all those streams updated. Of course, xMatters can do that, but as long as you guys are having a way that you do that, keep those updated is critical.
All right, great. Okay, another question here. Can you give some examples of the mean time to innovation in less than a few hours? It's a question from your MTTR, MTTI chart. My definition, what do you mean by innovation here could help in the understanding.
Sure. Well, the question is around my chart, I guess I'll start to answer. So MTTI means how fast can you deliver change into production. And the 1 hour that I had on there, that was kind of our goal from our CTO. When I told you in our transformation, the first thing we did is 1 hour code to production. That means he asked us that if we're running our software for thousands of our customers and something terrible happens and we need to provide a fix for it, we need to be able to deliver that through our pipeline within 1 hour. So the goal here is MTTI. How long does it take until I get a code change into production that is either providing a new value or fixing something? And what is interesting, what I typically do, and I've done a couple of workshops with organizations in order to figure out what does this MTTI currently look like. I typically sit down and say, let's make a simple change in a code file. Let's just add a comment field. So let's not even change functionality, but let's figure out how long it takes you currently with your processes, with all of your approval processes, with your test processes, until that change in the one code file, which is actually not even functional change, just a comment, how long it takes to be in production. And this is typically MTTI. So right, how long does it take to get out? So now MTTR, in case something is failing in production, how long does it take you to detect there is a problem, get the right people in place until it is remediated? And the reason why some organizations are doing extremely well in both of these areas is because they are enforcing and using some of these new deployment methodologies, right? They're using canary deployments, or they're using feature flags, which means you may have already deployed code in your last deployment cycle, and now with the feature flag you can turn it on for a particular set of users. You monitor immediately, get feedback if this is good or no good, and then you can immediately react to that by saying, well, it's actually for the 5% of users it looks like it has a negative impact, so let's actually roll it back, and with this we've mitigated the impact. Right? I hope this kind of makes sense. Travis, does my explanation make sense?
Yeah, I think you're right on.
All right, great. Plenty of time for questions, guys. If you have one, please go ahead and use the GoToWebinar control panel and submit your question. Let's see, next question here. Can you please talk about the use of unsupervised learnings like hotspot or anomaly detection techniques for self-healing or alerting?
And do you want to start on the self-healing part of that?
Sure. So obviously I'm a little biased because I know how we do these things with Dynatrace. And so what we do, once you install the Dynatrace agent, we instrument your complete stack from host over your processes, your containers, code level. We do end-to-end transactional tracing. We've been doing this for 15 years now, and I think we know how to trace these transactions end-to-end with code level visibility without incurring the overhead that you don't want to have. Now, but to your question, supervised learning, what we do is we look at things like response time, failure rate, throughput, your memory consumption, your user behavior. We also do end user monitoring. And what we do is we do multidimensional baselining. So we don't do any magic voodoo machine learning and AI. I know that everybody's talking about they have the latest and greatest AI. if you look at some of the material that we put out there, we are very specific, and we talk about that our AI is a deterministic AI engine with clear rules that are combined with baselining that is baselining data with high quality. So our agents collect a lot of high quality data by then applying rules that just apply to distributed systems. So we know how garbage collection impacts CPU. We know how a queue to a different system that is made running full is impacting the caller or the callee. So we are applying all of this and therefore then alert on an abnormal behavior. And we also then are able to say, where are your root causes? Where are your hotspots? How is behavior change in one part of your infrastructure impacting another part of the infrastructure? And that's possible because we know your end-to-end traces and we know how your systems are connected. So that's why this is the way we work. And there's a lot of material out there about our Dynatrace Davis deterministic AI engine, a lot of papers, a couple of PhD guys have figured out all the right algorithms and the right statistical approaches so that you can actually see what we do. But the most important thing is the underlying data, which is very high granularity, which is very good. And then we can apply all the stuff on top.
Just to pile on there, I think there's there's also a little bit of the the marketing fluff, I guess. That AI is going to fix everything, that you can kind of just, plug in this kind of AI thing and plug everything into it. But, ultimately there's going to be things that, it's not going to catch, or, or this engine, or, or that engine. So I think you're still going to have alerts, at some point. It's not like you want to say, okay, we're going to plug in this AI system, or even Dynatrace, and just say, okay, it's going to fix everything. Have this massive self-healing, thing, and then we don't have to worry about alerting. And I think, the alerting, if nothing else, is your ultimate safety net, right? So that you can be sure that you are getting people aware of, potential customer impacting issues. So it's not like we will ever get away from alerting. I think it's just more of cutting down the stream so that you're not automatically alerting on just these little things that could be actually remedied by self-healing before it even impacts a person. The SRE handbook has nice metrics for trying to keep dev teams or SRE teams into 50% feature velocity, because a lot of they say almost 50% of your time is taken up by 50% of the time is taken up just by other tasks. So if you're starting to have to deal with, more and more alerts, that's going to impact your feature velocity. So that's ultimately what you want to take care of.
Okay.
I hope that answers the question.
All right, great. Next question, it just came in. Hope it doesn't start a war, but the question is, why does everyone keep saying AI when it's actually plain old machine learning?
Yeah,
I agree.
Because there's a lot of creative, as I think you just said, there's a lot of creative marketing folks out there that know what terms sell well and what get people's attention. But I think we both made it clear that what we actually do, and I hope at least we from a Dynatrace side, we are clear. We have a lot of data, and then we run our algorithms on top of it. And you can read about every statistical approach we use to baseline the different metrics, whether it's response time, throughput, failure rate, or your memory behavior. And you're correctly right. So it's like many terms that have been used in the past that people got kind of excited about, and then they have been abused and misused to just stir attention, where underneath the hood it's just crunching through a lot of data in the end, right? So, but what I want to also say is, that's what I tried to say earlier. If you have the right data, especially if you have the dependency information about which service calls which service runs on which machines, you don't need, let's say, machine learning to figure out that garbage collection on one side has an impact with the connection pool on another side, right? If your systems are connected, I don't need don't need machine learning to figure the dependency out. If you know the dependency and we know the rules in distributed systems, there's clear rules of engagements in distributed systems. This is what we built into our deterministic engine. And yes, we call it deterministic AI engine. What it is, it's crunching through a lot of data in a smart way. That's what it is.
All right, great. We're about 6 minutes to the top of the hour. I think we have time for one more question before we close things out. Let's see. What is a realistic time frame for enterprise transition from on-prem ops to NoOps?
I think it's a loaded question.
Yeah.
It is.
I think there's a lot to unpack there.
Yeah, so I think the question is, as a whole organization, it's probably pretty hard. We also did it step by step, and I was just in a tour through Ohio last week where I talked about kind of our transformation from DevOps to NoOps to what we now call autonomous cloud, right? So scaling NoOps. It took us, a couple of years to get there, and I got feedback from organizations in the Midwest of the United States, and they told me that they're also in this transition. And what I see with most organizations is that you typically start with a new project or with one project that you're trying to figure out how can we do it differently. And then once you've mastered it, then you try to figure out how you can scale it to the rest of the organization. But I guess I don't tell you anything new here, but you don't do a big bang, but you try to figure out how can this work, especially how does this new model fit into your current organizational structure. Maybe you need to change organizational structures, and how can you then scale it, right? And so I would say for an enterprise that is large, that has a lot of structure and a lot of history, I'm sure it won't happen overnight, but you should start small, improve the value of the change, get people excited, and then scale it to the rest of the organization.
Yeah, I listened to a talk a few weeks ago that talked about also being intelligent about which projects to take down first. You don't want to start with the most massive critical piece of your entire architecture. Take something, maybe not the smallest, easiest, less critical piece, but somewhere in the middle that makes sense to kind of take down, because a lot of it, especially in the beginning, is going to be a lot of learning where you're just like, okay, how do we get our heads wrapped around this? And ultimately, it's going to evolve. What you start with, and you're like, okay, this is definitely where we're going to go. Some years down the line, you can be like, yeah, that's not where we went, and intelligently decided to pick, your way through that. So I think it's very, starting small, being, as much as I hate to say it, agile, but being able to pivot, to things.
Sounds an awful lot like the transition to DevOps, right? You want to start,
exactly.
It's iterative. So, yeah. All right, great. Well, we're about 3 minutes to the top of the hour, so we're going to have to close out the question and answer period of today's webinar. I do want to thank everybody who did submit questions, and please know if we didn't get to your question, the folks at xMatters and Dynatrace will be getting a copy of all of the questions that came in, and I'm sure one of them or somebody from their organization will be more than happy to follow up with you offline.
Sure.
Also, definitely. Before we go, I want to remind the audience that today's event has been recorded. So if you missed any or all of the event, or if you just want to watch it again, you'll have the opportunity to do so. We will be sending out an email after today's webinar that contains a link to access the webinar on demand. And the webinar is also going to be living on the DevOps.com website, so you can always go find it there. Just go to DevOps.com/webinars, look in the on-demand section, and it should be right there waiting for you. All right, one last thing before we close it out for today. At the top of the hour, I did promise a, what are you doing, Travis?
I was getting excited. This is the best part.
All right, yeah, the best part. We're doing a drawing for 3 $50 Amazon gift cards. I thought your hands were cold or something. So without further ado, let's go ahead and do that drawing. Our first winner is Beth S. Congratulations, Beth. Our next winner is Chris B. Congratulations, Chris. And our third winner is Deborah P. So congratulations to all of you. We'll be following up with you via email to get you your $50 Amazon gift card. And yeah, I guess that's about it. I do want to thank Travis and Andi for joining me today. Great presentation, guys. Lots of really great information, and judging from the questions we got, I know the audience got a lot out of it too. So thanks again, appreciate it.
Thanks for having us on. Appreciate it.
Thank
All right,
you.
awesome. All right, I want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.
Bye-bye. Happy
Bye.
Wednesday.